Ever since this Iron Man LEGO set came out, I wanted to buy it. Almost every section uses clever techniques and the new pieces to solve problems I've struggled with in my own builds. So instead of reviewing it like everyone else, let's learn every useful trick we can find and use it to build better MOCs. I've grouped these tricks into chapters and arranged them from the simplest idea to the most advanced techniques. Okay, let's get into it. Welcome to Brick Creations. Chapter 1. New LEGO Bricks. This set honestly couldn't exist 1 year ago. Not because of its design, but because some of the key pieces it uses, well, didn't exist yet. For example, these Technic rotation discs with pin connections were just released in 2025, and they're used in this set to create the waist rotation. The earlier rotation discs were not attached to pins, but to Technic lift arms, causing them to be relatively bulky, which prevents them from being used in tight spaces. Also, the axis of rotation was not in the center, but rather on the edge, which made it more challenging to incorporate in some design. But the new ones, which are terminated by pin connectors, are compact and the axis of rotation runs through their center, which allows them to be put into tighter spaces. Another piece is this 2x2 curved round corner, which was also introduced last year. While it doesn't solve a technical issue, it really helps with polishing in the final model. You see, LEGO has these 2x1 and 2x2 curved slopes. They are one of the most used pieces for detailing curved features. The problem occurs when we have two of these pieces at 90 degrees and we want to connect them without breaking the curvature of the surface. This 2x2 curved corners do just that, allowing us to have better polished results. They are so useful that they're used in the back of the hands, his helmet, his hips, and his arms. But my favorite new piece is this curved bar. It's actually one of the reasons why I was interested in buying this set. I've seen the ads and I was intrigued at how they made the fingers look so natural. Then as I built it, I realized that's thanks to these bars. You know, it's very challenging making the fingers come out at normal looking angles. It is common using these hinges, but the problem is that all the fingers would be parallel and we can only stack 3 of them. Frankly, they look more like Wolverine's claws than fingers. Another typical piece is this hinge here, which gives a better final look, but the angle between the fingers is quite large and it looks more like a chicken feet or something. But with this new bar here, we can fit 4 fingers at just the right angle to look like an open palm. So I'm really happy they made this new bar, and I will definitely copy this design for future builds. Chapter 2. Reversing Building Directions. Okay, let's get more technical. LEGO has far more pieces that can be placed on top of the studs than can be placed under the studs. This means if we want to create slopes or curves on the opposite sides of the build, we will need to reverse the building directions to have studs or anti-studs in both directions. This set used multiple stud reversing techniques. Here are 2 of them, and actually the second one is new to me. One way of reversing the building direction is to use an axle and connect it to pieces with axle holes in opposite directions. The final result will have studs on both directions. LEGO used this technique in reversing the building directions on Iron Man's back, and also on his legs to attach curves and slopes in opposite directions. I personally like this technique because the final build is quite sturdy. However, it needs 2 bricks thicknesses to implement, so it cannot be used in very tight regions. The second technique uses this piece, which is basically a brick with bars inside. Personally, it never crossed my mind that this piece can reverse directions, and it's actually quite simple. Just connect plates with clips to this brick facing the opposite direction, and here you go. Now you can build on both sides. Quite neat. It's used to reverse the building direction on his lower back. Compared to the axle technique, it can be more compact as it only needs 1 brick thickness to implement. However, in this set, they only add this connection on one side. which allows for some movement and risks the integrity of the build. If it was up to me, I would have added this connection in opposite directions to make it more stable and less prone to breaking. Chapter 3. Building at any angle. The LEGO designers attach Iron Man feet to the base at an angle, with ball joints and pin connectors, to create this natural standing look. While I was filming this section, I decided to expand on this connection and accidentally came up with a whole geometrical theory on how to attach pieces at different angles. Let me show you. Let's say we have these two pieces that we want to connect at an angle. It's not trivial, because let's say they'll be attached at this corner. Now we need to find another stud that intersects both of them as well. So here's the trick. Imagine we have a mirror here, and that the yellow plate is the reflection of the black plate. So think about it. If we make any two studs from the black plate intersect the mirror, which is easy, then the reflection studs in the yellow plate will also intersect the mirror. So if the mirror intersects the plate at these two studs here, the reflection of these two studs will also intersect the mirror, and so we can attach them together. Now if we turn it like this, and it's now intersecting at different studs, we just need to rotate the reflection at the same angle in the opposite direction, and attach both at the mirror intersection. And basically this allows us to connect them at different angles in a logical, geometrical way. So no need to guess. Whatever the angle you make with the mirror here, the final connection angle would be its double. I think it's pretty useful. And this is exactly what they have done here. We can look at the angle here. It's half a brick in the horizontal direction and then 2 bricks in the other direction, which is exactly mirrored on the shoes. Half a brick in the opposite direction and 2 bricks here. And that's how they're getting this angle. Chapter 4. Hiding articulated joints. This might be the smartest solution to a common problem in the entire set. Iron Man's Mark III arms are well articulated, but this comes at a high cost. This large void here. If the designers built this region to cover the connection point, they would limit the movement, just as how they did to his hips joints. On the other hand, if they left it uncovered, well, it would look very unpolished, which is okay for cheaper builds, but would be unacceptable for a collector build. This is how they resolved this issue. They used these new dome pieces which are hollow from inside, making them great at covering parts without taking much volume, unlike the older dome pieces which were not hollow. Then, to cover the joints while allowing the arms to move, these dome pieces need to move as well. So the designers used these plates with bars to create joints on the arm and attached the hollow domes to these joints. Now, if the arms are raised or lowered, the dome can move to cover the joint, making the build well polished without losing the articulation. Hey, I'm working on a new build right now, and I'm definitely copying this idea. Maybe not with the same pieces, but with the same concept for sure, to cover the articulation points. So make sure you're subscribed if you don't want to miss it, and back to the video. In the next chapter, I will show you an approach that I use all the time in my own builds. But before getting into that, here are some honorable mentions. Chapter 5. Honorable Mentions. 1. If you have a repeating shape, use different pieces to make the final look more interesting. Like here for example, to create his waist curvature, the designers used this 4x3 stepped wedge on the front. They used 1x4 curved slopes on the sides, and 2x2 inverted curved slopes on the back, all to create more or less the same geometry, to make it less repetitive. I actually learned this the hard way when I built the Founding Titan, and his ribs build was too repetitive. Number 2. Half plate offsets. Many pieces like this 1x4 curved slopes end in a half plate thickness. If we want, for example, to continue the surface with this G slope, which is 2 plates thick, and only use plates, they will never align perfectly. This is where we use brackets and headlight bricks to shift half a plate for smooth, polished looks. This is well demonstrated in the suit's legs. Number 3. And finally, don't guess proportions. In this set, the leg connections are placed at an angle to mimic the pelvis bones, where the hip joints naturally come out at an angle. In your own build, try to use reference image anytime you can to get the connection right before adding other surface polishing pieces. This is exactly what I did in my toothless mock, where I used references of quadruple animal legs and bat wings to design different parts of his body. Chapter 6. Designing 3D geometries. Visualizing what piece to use to create a 3D shape can be very challenging. And so, over the builds I've designed, I found this approach to be one of the easiest ways to tackle that problem. Let's say we want to build this random 3D shape in LEGO. If we try to build the entire 3D shape at once, it can be difficult to figure out where all the pieces should go and what parts should connect together. Instead, start by drawing the 2D outline of the shape. Then, build only the outer contour in LEGO. Next, add bricks with studs facing outwards inside the build, like this. Finally, we can now build the third dimension independently with curves and slopes. By separating one big problem into two smaller ones, designing complex 3D shapes becomes more manageable. I think this is the approach used by LEGO to design Iron Man's legs. First, a 2D contour of the leg was built, and they made sure to have studs facing outwards. Then, the third dimension was built independently and attached to the structure. They also used the same technique in his helmet. They built an almost 2D helmet without any curvature in the third dimension, had studs on both sides, then added the curves and slopes to build the third dimension. So it's a very useful way to approach complex 3D shapes. I've actually used this technique to design Shadow's complicated 3D quilt. Here I built 2D contours, made sure I had enough studs on both directions, then used the slopes to create the curvature. The biggest takeaway here is not the specific pieces LEGO used, but the thought process itself. I knew from the images that this set would be well polished, but I didn't expect it to be this educational. I've learned a lot from it. I'm currently finishing a build of a character that was a big part of my childhood, and I have already used a few of these ideas in it. So if you want to see how that turns out, make sure you're subscribed. If there is a technique here that stood out to you, or if you think I missed something interesting in the build, let me know in the comments below. I read all of them. Okay, see you in the next one. Bye for now.